Let's talk now about processes. A process we can think of as an abstract virtual machine. It has its own CPU, conceptually, and its own memory. So this is an abstract virtual machine. How do we get its own memory? Well, this is with address spaces. So we have our own address space for each process. If you have threads within a process, they share an address space. And then with the CPU, we're going to do this in terms of time slicing. That is, if we have a single CPU, we can share that CPU by giving small quanta of time to each process. So there are different APIs dealing with processes. For instance, we can fork to create a new process. We can exec to replace the image of an executable in a process. Wait will wait for a child process. Kill will kill another process, basically, stop it from running. sbreak extends space, and getPID gets the process ID. So one challenge is we often have more processes than we have processors, right? We've got, let's say, 2 processors on your laptop, and you want to edit in Vim and run the compiler and play some music. So you've got to do some multiplexing. So we're trying to multiplex, let's say, n processes among m processors, okay? Where m may be less than n. So this is called time slicing, time sharing, context switching, scheduling. All those are equivalent terms for the same thing. Our goals are that this is transparent to the user process. That is, the process doesn't have to know it's being multiplexed. Okay? We want this abstract virtual machine where the process can just think it has a CPU. So that means that since it's transparent, we don't want to have any calls to yield. Right? Within the process, we don't want to call yield. And it's also, we want to be preemptive. So in the user process, no calls to yield, preemptive. In the kernel itself, we'd like it to be preemptive when it's convenient. So that helps to keep the system responsive, where we're not stuck inside, let's say, a system call for a long amount of time. What we're going to find is for the kernel, at least for xv6, we're going to look and see that we will be somewhat preemptive in the kernel. JOS, on the other hand, has no preemption when you're in the kernel. And part of what allows that is the fact that no system calls take very long.